2. The first question is there a greatest common factor? Which most of you can see a 2 can come out of all of this, correct? Mm-hmm. That would lead you to 2, 4x squared plus 4x plus 1, right? So we've pulled that out and we have this trinomial. Before we believe we're done, we need to ask ourselves, is this the difference of two squares? No. Is this a possible perfect square? Well, is the first term a perfect square? Yes. Write down its root in the first position. Is the last term a perfect square?
Yeah.
Yes?
Yeah. One by one.
Can I multiply this times this and double it to get the middle term? Yes. What must the sign be to get a positive 4x? Plus. So your factor includes the 2 and then all of this. Or most of you would prefer to write less things. That is sufficient. As a matter of fact, when you check answers in the back of your textbook, that's what they'll look like. Okay? This is the same thing as that. Okay, that's 33. $35. 9 minus 72m plus 144m squared. Is there a greatest common factor to all of that? We know these are divisible by 9. Is that? I'm going to check. Why, yes, it is. Each of these are divisible by 9. So if I pull a 9 out, I end up with 1 minus 9m plus 16m squared. Now I know you might look at this and say, well, this can't be a perfect square because this thing should be first, this thing should be second, and this thing should be third. But the arrangement still works, it's just inverted. So as long as it's flipped this way or that way, it can still be factored as a perfect square. Incidentally, if it was all jibber-jabbered, like negative 9m plus 1 plus 16m squared, you could rewrite it so that it's in order like this, so that it looks more familiar to you.
The order doesn't matter then.
Well, what it does is it puts it back into a squared plus bx plus c form. It puts it back in the form you're used to seeing. Is 16m squared a perfect square? If so, what's its root?
4m.
Yep. Is 1 a perfect square?
Yes.
Goodness gracious. If I multiply 4m by 1 and double it, that should be an 8, Mrs. Myers. How come nobody yelled at me? 9 times 8. If I multiplied 4 by 1 and double it, will I get an 8? Because 9 times 8 is 72, not 9 times 9. Yes, if it's a negative. So this answer is fine. The faster answer is 9 4m minus 1 squared. Okay, sorry about that. That's 35. The rest of it, they just look harder, they just look scarier, but it's the same steps. Is there something you could pull out and we're still looking for perfect squares? So here's 37. I'm going to do as many of these as I can, and I'm actually going to move on here to the next group here in a second. X to the 5th plus 2x to the 4th plus x cubed. What can I pull out of all of these? Guarantee you there's a greatest common factor. X what? X cubed. Good. X cubed causes me to have x squared plus 2x plus 1. Okay? And if you're not sure, x3, x2, yep, that equals x5. x3, 2x, yep, that equals 2x, 4, x3, 1, yep. Square roots, wherefore art thou square root? Is that a perfect square? Is that a perfect square? What must the sign be to multiply together and be doubled to create a 2x? Plus x cubed, x plus 1 squared is the factor. Okay. Ugh. I'm moving on to number 43. U squared minus 2u plus 1 minus v squared. Is there a greatest common factor of all this? No. Are there any recognizable patterns? Well, right here is a perfect square. And I'm only going to write it like that because I just don't have a lot of time. U minus 1 squared will produce this. U1 has to be negative to produce that center. Okay? This is this. But we're not done. We have minus v squared. Okay? This is where I'm going to blow your mind. This is now the difference of two perfect squares.
Oh, I see where it goes.
Uh-huh. Instead of it being like 49, and you take the root, which is 7, it's u minus 1 times u minus 1. So let me show you how that's going to look in your answer. I'm going to start with this piece. The square root, the square root. So something minus something, something plus something is how you factor a difference of squares. Now I also need the square root of u minus 1 squared. So that's u minus 1. The square root of something squared is the something. Okay? Take, for example, the square root of 12 squared is 12. Okay? Because that's 144, right? The square root of 144 is 12. Well, if I say it this way, you just take the item itself.
Ta-da.
And there's your answer. Yeah, that's ta-da for sure. It might get tricky though, and that's the next one I'm going to show you. This is number 45. It's another 4-part jobber. A squared minus b squared. Oh, there's a difference of squares right off the bat. Plus 6b minus 9. But then you got that weird thing. Okay. Well,
Got it.
you do?
I believe so.
Awesome. Okay. If you factor out the negative symbol from this trio, this trinomial, you now have b squared minus 6b plus 9, which is a perfect square. It is b minus 3 squared. And I know you're thinking, how do you know that so fast? Well, yeah, I've done these a few more times than you. But square root of this is that, square root of this is that, has to be a negative to be doubled and create that. Again, we now have a difference of two perfect squares. Here's the factor. A plus, a minus, the square root plus, the square root minus, and here's the other square root. And you don't change the b minus 3 because that's the square root of that. Just like a is the square root of a squared. Okay, that's number 45. Okay. I only have you guys going up to 46, so you don't have to go any further than that.